Hello students, welcome you all for the today's lecturing session. I am Krishna Prasades from the Department of Mechanical Engineering, MIT Mysore. Next, very important topic, it is called India's production and reserves of commercial sources. We have already told what is meant by the commercial energy sources. So energy sources which are available in the market for the definite price, that is called commercial energy sources. So in India, the main commercial sources are fossil fuel, then hydropower, then nuclear power and other non-commercial energy source. Okay, so here very important one is called fossil fuel is one of the important fuel in the development of power in India. So especially that is called solid fuel like coal, then liquid fuel like oil and natural gas, and gaseous fuel called natural gas like LPG and CNG. Similarly, we can also see the hydroelectric power station in all over the country, then nuclear fuel especially in Kalpakam, Tamil Nadu, then Narora, Uttar Pradesh, then another one it is called Tarapur in Maharashtra. So here very first important thing in the fossil fuel, that is called coal. Okay, then what is meant by the coal? Coal is highly carbonaceous material obtained from the decay of plants, and it is subjected to heat and pressure under below the earth's surface from million or hundreds of years. That means it is subjected to heat and pressure in the swamp environment in order to build the heat energy in the coal. Okay, and based on the percentage of the carbon, this coal it is categorized into 4 types. Okay, if the percentage of carbon it is 60%, then the coal it is called as the peat. If the percentage of the carbon it is 70%, then coal it is called lignite. If the percentage of the carbon it is 80% in the coal, then it is called bituminous coal. Similarly, if the percentage of the carbon is 90% in the coal, then it is called anthracite. And very important one, it is called what is the estimation or recoverable resources available in India, that is around 1,48,079 million tons. Okay, so here in India we are having 1,49,079 million tons of coal recoverable resources are available, but out of which we are utilizing only 80,000 million tons. Okay, we are utilizing only 80,000 million tons. That means the percentage of utilization, especially in the coal, it is 55%. Okay, so total recoverable reserves available in India for the coal, it is 1,48,079 million tons, out of which we are utilizing 80,000 million tons, and the percentage of utilization it is 55%. And why India it is mainly depends upon the coal? Because coal is easily converted into other forms of energy, that is like oil as well as the gas. So that's why India it is mainly depends upon the coal. Next, very important one, it is called oil and gas. The demand for the fossil fuels increases rapidly due to the growth of industrialization as well as the transportation service and the population. That's why government of India felt the need for the exploration of oil and natural gas. That's why the government of India established ONGC in 1956 as well as Oil India Limited in 1959. And due to this, we are going to estimate that how much amount of oil and gas it is available in India. That is, for the oil we are having 550 million tons reservoirs. Similarly, for the natural gas it is 500 cubic tons. Okay, so the total recoverable reservoirs available in India for the oil it is 550 million tons, and for the gas it is 500 cubic tons, but the utilization it is only around 54 million tons. So this is only around 10% of total potential. So that is regarding to the oil as well as the natural gas. Next very important one, it is called hydropower. So hydropower, it is the one of the most important and economic in the development of power in India, and also India made the remarkable development in the development of power generation, especially for hydroelectric power generation. Okay, so why? Because it is the most economic in development, as well as no waste disposal problem, as well as no environmental pollution problem. That's why India made the remarkable improvement in the hydroelectric power generation. And in the hydropower, we are having total recoverable reservoirs, it is 90,000 megawatt, but the utilization it is only 18,000 megawatt. That is 20% of total potential we are utilizing, that is around 20 to 22%. Okay, next it is very important one, it is called nuclear power. So the India is also developed the nuclear power with the nuclear fission chain reaction. So, and the main sources for the nuclear power in India, that is called uranium, and another one it is called thorium. And for the uranium we are having the 70,000 tons, and for the thorium we are having the 360,000 tons of reservoirs. Okay, so because of the very high amount of reservoirs in uranium and thorium, Government of India established 3 nuclear power stations, that is called Kalpakam in Tamil Nadu, Narora in Uttar Pradesh, and then Tarapur in Maharashtra. So out of which we are utilizing only 3%. Next very important one, it's called non-commercial energy. So non-commercial energies are called fuel wood, that is 223 million tons, then agricultural waste, that is 65 million tons, and cow dung, yearly it is around 324 million tons, out of which we are utilizing only 10%. So this is regarding to the India's production and recoverable commercial energy sources. Okay, very first one it is called coal. The estimation it is around 1,48,079 million tons, out of which we are utilizing only 80,000 million tons, it is 55%. Similarly for oil we are having the recoverable resources, it is 550 million tons, and gas 500 cubic tons, out of which we are utilizing only 54 million tons, it is only 10%. Similarly hydropower we are having 90,000 megawatts, and we are utilizing only 18%, that is 22% of utilization it is possible in India. Then nuclear power, the 2 main sources are uranium, that is available 70,000 tons, thorium it is 360,000 tons, and non-commercial energy sources like fuel wood we are having available with 223 million tons, agricultural waste for the year we are having 65 million tons, cow dung it is 324 million tons. So we are utilizing for 3% and 10%. We can make a graph for this. It is for coal 55%, then hydropower for 22%, then nuclear power for 3%, then oil and natural gas for 10%, then non-commercial energy sources it is also for 10%. So then what is the need for non-conventional energy resources? That is very much important. We have seen that in India's production we are mainly concentrating on fossil fuels like coal. So very important one, it is called fossil fuels are finite sources. That means due to the ever increasing of or the demand of fossil fuels, their availability is rapidly declining. That is the one of the disadvantage. Okay, so we have seen that how much amount of reservoirs are available in especially for fossil fuels like coal, oil and gas. That means these fossil fuels are finite sources that are finally going to end in the next centuries. That's why we need to go for non-conventional energy sources like solar, wind, tidal and geothermal energy. Next, demand of the energy increases exponentially. Yes, obviously the demand for the fossil fuels is increases because of the rapid growth of industrialization and transportation services as well as the population. Therefore, this energy demand we cannot meet only with the help of the fossil fuels. That's why we need to harness in the other energy sources like non-conventional energy sources. Next, fossil fuels are contribute to the climate change. That means especially petroleum fuels as well as the nuclear fuels, by burning it, this releases the lot of hydrocarbons like carbon dioxide, carbon monoxide, nitrogen dioxide, sulfur dioxide. That's why we need to go for the clean energy sources like non-conventional energy sources. Next, large hydropower resources affects the wildlife. Yes, so large hydropower station, we need to have the larger area, so that will going to make the main problems like deforestation, and that will pose to the problems to the wildlife. Next, renewable energy is better for the environment. Yes, by using the renewable energy sources like solar, wind, geothermal, they are going to reduce the environmental polluted gases like carbon dioxide, carbon monoxide, nitrogen dioxide and sulfur dioxide. And also renewable energy, it is democratic in nature. That's why we need to use for non-conventional energy sources. Next, very important one. Then what is the purpose of energy alternatives? So in order to meet the energy demand as well as social and economical development, and in consideration of human health, alternative energy sources and like clean energy sources and their services is very much important. So that's why we are looking onto the non-conventional energy sources. So then what are the different non-conventional energy sources? The different non-conventional energy sources like solar energy. So solar energy, it is nothing but energy radiated from the sun in the form of electromagnetic radiation. Wind energy, it is nothing but kinetic energy associated with the large masses of air. Tidal energy, it is energy obtained from the tides of the ocean. Then geothermal energy, energy stored deep inside the earth crust. So these are some of the non-conventional energy sources. Then under the non-conventional energy sources, very first and important thing, it is called solar energy. So what is mean by this solar energy? Solar energy, it is the very large inexhaustible source of energy. So what is mean by the inexhaustible? That means it can be renewed within a short period of time if it is exhausted, and it will not going to exhaust at least in a time frame of human society, that is called inexhaustible. Okay, so solar energy, it is the very large inexhaustible source of energy. Also very important one, it is called solar power from the sun intercepted by the earth's surface. It is approximately 1.8 into 10 to the power of 11 megawatts, which is many thousands times larger than the present consumption rate of all the commercial energy sources in the earth. Okay, I repeat, power from the sun intercepted by the earth is approximately 1.8 into 10 to the power of 11 megawatt, which is many thousands times larger than the present consumption rate on the earth of all the commercial energy sources like fossil fuels, nuclear fuels, etc. So that's why we are looking onto the solar energy. Also, solar energy can be received on the earth's surface. It is either directly or indirectly, and it can be easily converted into either heat or electricity. So that is very much important. So solar energy, it is radiated from the sun in the form of electromagnetic radiation that can be easily converted into either heat or electricity. And also very important thing, it is called, whatever the solar radiation received on the earth's surface, it mainly consists of three regions. The one, it is called infrared region. This infrared region having 46%. Similarly, visible light, it is having also 46%, and very effective 8% of ultraviolet lights. So this is regarding to the solar radiation spectrum. And also very important one, how to utilize this solar energy. The solar energy can be utilized either directly or indirect form. So very first important thing, it is called solar energy utilization in the form of direct form, and another one, it is called indirect form. In the direct form, there are two types, that is called thermal conversion. Another one, it is called utilization with the help of photovoltaic effect. Then in the indirect form, we are utilizing in the form of wind, hydro, ocean and biomass. So this is the utilization of solar energy via directly as well as indirectly. So these are all called it as the indirect source of solar energy, that is biomass, ocean, hydro and the wind power, and the direct solar energy utilization, it is called thermal power and photovoltaic. Then what are the advantages of solar energy? It is very much important. First one, solar energy are environmentally clean source of energy. Very important, it is called. If you are using the conventional energy sources like nuclear fuel as well as the fossil fuel, when you are burning the nuclear fuel and the fossil fuels, it releases the lot of hydrocarbons like carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen dioxide. There is no such effects or happen in case of the solar energy utilization. Okay, next, available in adequate quantity. Yes, solar energy is available in adequate quantity in all parts of the world where people are live. So this is the second most important advantage of the solar energy. Next, there is also some kind of disadvantages are available in case of the solar energy utilization. Very first, it is called large collecting areas are required. In order to harness the solar energy to the useful purpose, large collecting areas are required. So that will going to increases the cost in many of the applications. So generally we see in the transport applications, like they are usually keeping the very large collecting areas like solar cells and the solar panels. So these solar panels are absorbing the solar radiations and converting the solar radiations into the electricity. So that will going to increase as the cost of utilization of solar energy. Next, dilute source of energy. Yes, solar energies are usually available in the dilute form. Even in the hottest region also, we are expecting the solar radiation, it is only 1 kilowatt per meter square. And for the whole day, we are receiving the total solar radiation, it is only 7 kilowatt per meter square. So this is very much little in terms of energy utilization. Okay. So next, very important one, it's called, its availability varies with time. Yes, solar energy utilization cannot be possible in the night cycle, and also it is depends upon the local weathering condition, and it is also depends upon the movement of Earth orbit around the sun. So these are the some of the disadvantages regarding to the solar energy utilization. Then what are the different solar energy utilization? So that is in the form of direct energy utilization. Very first thing, it is called thermal energy. So there are two definitions for the thermal energy. Very first definition is called thermal energy. It is nothing but internal energy present in a system in a state of thermodynamic equilibrium by virtue of its temperature. Okay, I repeat. So thermal energy, it is nothing but internal energy present in a system in a state of thermodynamic equilibrium by virtue of its temperature. Here thermodynamic equilibrium means here the system under the control of mechanical equilibrium, chemical equilibrium. But and another definition of thermal energy, it is nothing but thermal energy, it is nothing but heat energy. So heat energy liberated from a system when due to the rising temperature, it causes the atoms or molecule whatever present in a system move faster and collide with each other, and whatever the heat energy liberated, that means whatever the heat energy liberated due to the rising temperature, that is called it as the thermal energy. Okay, so for that you consider the three examples, that is called solid, liquid and a gas. In case of the solid, atoms or molecules are very compact each other, but in case of the liquid, atoms and molecules are having little bit of freeness, and in case of the gas, atoms and molecules are completely free. Whenever heat the body of the solid, then its temperature is slowly rises. Due to the rising temperature, whatever the atoms or molecules are present, they are going to collide with each other. So due to the collision, the heat energy will be liberated. Whatever this heat energy liberated, it is mainly depends upon three parameters. Okay, whatever the heat energy liberated, it is mainly depends upon the three parameter. First one, it is called the number of molecules present in the system. Okay, it is depends upon the number of molecules present in the system. Second one, arrangement of molecules. So I already told, in case of the solid, the atoms or molecules are very compact each other, but in case of the liquid, having the little bit of freeness. That is called arrangement of molecules. And third one, it is called temperature of the heated object. Okay, these are the three parameters are very much important during the liberation of heat energy from the body. Okay, I repeat, what is meant by the heat energy or thermal energy? Thermal energy, it is nothing but the heat energy present in a system. Due to the rise in temperature, the atoms or molecules to collide with each other and they will liberate the heat energy. So that is called it as thermal energy. Okay, it is mainly depends upon the three parameters, that is called number of molecules present in the system, arrangement of molecules, temperature of the heated object, and also there are different modes of thermal energy transfer. So different modes of thermal energy transfers are, first one it is called conduction, second one it is called convection, and third one it is called radiation. So what is meant by the conduction? Here thermal energy transfer is mainly because of the direct contact. So this happens in case of the solid body because of the atoms and molecules are compact each other. Whenever due to the rise in temperature, these atoms and molecules are move faster and collide with each other, hence the heat will going to liberate. So this happens in case of the solid body. I repeat, what is meant by the conduction? Here thermal energy transfer takes place due to the direct contact. Next, second one, convection. Here thermal energy transfer takes place due to the movement of the liquid or gas. So this is called as the convection. The convection, it is usually happen both in case of the liquid as well as in the gas. Third one, the radiation. Thermal energy transfer is mainly because of the electromagnetic radiation, then it is called radiation. Okay, so next, second very important one, it is called liquid flat plate collector. So this is the one of the best example for solar thermal energy conversion. Okay, so this working of liquid flat plate collector we are studying in the first year level itself. Okay, so what are the important parts of the liquid flat plate collector? First one, absorber plate. Second one, water tube. Third one, transparent glass cover. Fourth one, insulation. So what is the purpose of the absorber plate? This absorber plate, it is usually made up of copper and it is coated with black in color in order to absorb all the solar radiations are falling on it. Then water tubes. Water tubes are the metallic tubes through which water circulates. Okay, then both absorber plate and water tubes are having the direct contact with each other. Then third one, it is called transparent glass cover. So this transparent glass cover, it is a toughened glass of 4 to 10 millimeter thickness. Okay, transparent glass cover is a toughened glass of 4 to 10 millimeter thickness, and the important working of the transparent glass cover is called, when solar radiation passes through the transparent glass cover, it allows the incident radiation back to the absorber plate. That means heat remains trapped in the air space between the transparent glass cover and the absorber plate. That means whatever the solar radiation incident on the absorber plate, and if some amount of solar radiations are reflecting back to the atmosphere, then this transparent glass cover does not allow it. That means whatever the heat present in the air space between the transparent glass cover and the absorber plate, it remains there. That means there is a complete utilization of heat energy. Then insulation. This insulation is provided below the absorber plate in order to prevent the heat losses by conduction process. Okay, next, how the working of liquid flat plate collector. This liquid flat plate collector, it is mainly used for low temperature applications like heating and cooking purpose. Okay, so we all know that in case of the solar water heater tank, we are having the two tanks. The one it is called overhead tank, other one it is called cylindrical shape of solar water heater tank. Okay, so initially the overhead tank, it is connected to the input of the liquid flat plate collector, and the output of the liquid flat plate collector, it is connected to the solar water heater tank. Initially, water from the overhead tank is made to passes through the water tubes of the liquid flat plate collector. When solar radiation is passes through the transparent glass cover, it falls on the absorber plate and it absorbs the heat energy. Whatever the heat energy absorbed by the absorber plate, it is then transferred to the cold water flowing through the water tube. Okay, so due to the heating, the cold water get converted into the hot water, and the density of the hot water, it is always less than the cold water, hence it is rises up and it is get collected in the solar water heater tank, and then it is used for various applications. Okay, I repeat the working. So here it mainly consists of 4 parts, that is called absorber plate, water tube, transparent glass cover, insulation. Initially, water from the overhead tank is made to flow through the water tubes of the liquid flat plate collector. When solar radiation passes through the transparent glass cover, it is falls on the absorber plate. Then the absorber plate absorbs the heat energy. The heat energy absorbed by the absorber plate is then transferred to the cold water flowing through the water tube and gets heated up. The heated water being lighter in density, hence it is rises up and collected in the solar water heater tank. Okay, so this is the working of liquid flat plate collector. Welcome back, students. Next, we are discussing with the solar photovoltaic cell. It is also the direct form of solar energy utilization. This photovoltaic cell, it is working on the principle of photoelectric effect. That means it is used to convert the solar energy into electrical energy. And this solar photovoltaic cells are usually consists of solar panels, and these solar panels are composed of solar cells. And these solar cells, it is usually made up of semiconductor materials like silicon. Next, here very important one, it is called the construction as well as the working of solar photovoltaic cell. So these solar photovoltaic cells are usually made up of semiconductor materials like silicon. Here the one layer having the p-type silicon and it is positively charged, and another layer has n-type silicon and it is called negatively charged. And here the positively charged p-type silicons are having the holes, and similarly the negatively charged electrons are containing in the n-type silicons. And the interface between p-type silicon and the n-type silicon, it is called p-n junction. Okay, so I repeat, the construction, it is mainly consists of positively charged holes in the p-type silicon and the negatively charged electrons in the n-type silicon, and the interface between these two junctions, it is called it as the p-n junction semiconductor material. And over the p-n junction semiconductor materials and p-type silicon and n-type silicon, the anti-reflective film, it is also provided. Okay, next very important one, what happens in the p-type silicon and what happens in the n-type silicon. These p-type silicons are having the large number of concentration of holes, and these holes are always having an affinity to move towards n-type electrons in order to combine with large number of electrons concentration. Similarly, what happens in case of the n-type silicon, here it having the large number of electrons concentration, and these electrons are affinity to move towards the p-type silicon in order to combine with large number of holes concentration. This charge distribution across the junction gives rise to electrical field, and potential difference is going to develop across the junction. Okay, so this is actually the principle of solar photovoltaic cell. Then what happens in case of the working? When these solar photovoltaic cells are exposed to the sunlight, then as soon as solar radiation it is incident on the solar photovoltaic cell, some of the solar photons will have a tendency to dislodge or eject the free electron from its fixed position in the material. Once the electrons are ejected from its fixed position in the material, it have an affinity to move towards positively charged holes, and the movement of this negatively charged electron from the n-type silicon to the p-type silicon constitutes electric current. We all know that what is meant by the electric current. So electric current, it is nothing but the movement of negatively charged electrons. Okay, so hence the electric current is going to develop. So photovoltaic cells are usually made to convert the solar radiation into electric current. Okay, so that too with the help of the p-type and n-type silicon. So next very important one, it is called hydropower. Okay, so what is mean by the hydropower? The power obtained from the kinetic energy of falling water or the flowing water, it is called as the hydropower. And what are the different methods of harnessing the hydropower? So different methods are harnessing the hydropower with the help of the water turbines like Kaplan turbine, Francis turbine and the Pelton wheel. Also it can be harnessed with the help of the ocean thermal energy conversion plant. Okay, so then what are the classification of hydropower? This hydropower can be classified into two types, small hydropower and micro hydropower. In case of the small hydropower, we can obtain the power from 100 kilowatt to 1 megawatt. Similarly, in micro hydropower, we can develop the power from 5 kilowatt to 100 kilowatt. So that is very much important. And the calculation of power and the formula, it is nothing but it is rho into Q into H into G. So here rho represents the density of the water and Q it is called as the flow rate and H it is called as the head of the water or height of the water and G it is called as the acceleration due to gravity and N it is called as the constant, and this is does not having any units. Then very important one, it is called classification of water turbine. So basically hydropowers are harnessed with mainly with the help of the water turbines like Pelton wheel, Francis and Kaplan. First one, the classification of water turbine based on the or according to the head. So if the height of the water it is below 30 meter, then it is called as the low head turbine. If the height of the water is in between the 30 meter to 150 meter, then it is called as the medium head turbine, and if the height of the water is above 150 meter, then it is called high head turbine. So similarly, the water turbine it is also classified based on the according to the type of energy available at the inlet of the turbine. If only kinetic energy available at the inlet of the turbine, then those kind of turbines are called as the impulse turbine. Similarly, if the both potential and kinetic energy available at the inlet of the turbine, then it is called as the reaction turbine. Next, third type, it is called according to the direction of flow of water through the runner. The runner, it is nothing but whatever the blades we are using in order to convert the kinetic energy of the water into mechanical energy in the form of rotation of the shaft, that is called as the runner. If the flow of water through the runner in the tangential direction, then it is called tangential flow turbine. If the direction of flow of water through the runner in axial direction, then it is called axial flow turbine. If the direction of flow of water through the runner in radial direction, then it is called radial flow turbine. And based on these parameters, the water turbines are anywhere in the world, it is classified into three types, that is called Pelton wheel, Francis and Kaplan turbine. Next very important one, we are taking an example of Pelton wheel for harnessing the hydropower. So what are the main important parts of the hydroelectric power plant? So the hydroelectric power plant, it is mainly used to convert the kinetic energy of the water into electrical energy. And the main parts of the hydropower, it is called first one dam or reservoir, and this dam or reservoir is constructed across the flowing river in order to increase the level of the water, that means in order to increase the potential energy of the water. Next, penstock. Penstock, it is a large pipeline which connects the reservoir and the turbine house, and the turbine it is used to convert the kinetic energy of the water into mechanical energy in the form of rotation of the shaft. Then generator, the generator it is usually coupled to the turbine in order to convert the mechanical energy into electrical energy. Then last one is called draft tube. The draft tube, it is a tube or a pipe or having the increasing area, it is used to discharge the water from the turbine into the tail race. Okay, so next, initially water from the reservoir having the very high potential energy, it is enters into the nozzle through the penstock. So here is the nozzle. Okay, so initially water from the reservoir having the very high potential energy enters into the nozzle through the penstock. In the nozzle, the potential energy of the water is completely get converted into kinetic energy. Then kinetic energy of the water is made to flow over the turbine, which converts mechanical energy in the form of rotation of the shaft, then which in turn drives the generator to produce electrical energy. Then water, after performing its work, is discharging into the tail race through the draft tube. So next, very important one, and the last in the today's session, it is called wind power. So what is mean by the wind power? So wind power, it is nothing but, or wind energy, it is nothing but the kinetic energy associated with the movement of large masses of air over the earth's surface. And how wind is obtained, that is very much important. The wind are caused by the two main factors. The first one, it is called heating and cooling of atmosphere, which generates the convection current. That means the heating, it is obtained due to the absorption of solar energy. That's why the wind energy, it is called as the indirect source of solar energy. And also the wind, it is also obtained because of the rotation of the earth orbit around the sun. Okay, then whatever the power obtained by the wind power, it is given by the formula half into density into area into velocity. That means whatever the wind power we are extracted, it is mainly depends upon the three parameters. The first one, it is called wind speed. Okay, then second one, it is called wind direction, and third one, it is called area of wind swept by rotor. That means, so these are the rotors of the windmill. So whatever the area of this rotor and whatever the wind can be extracted within this rotor area, so that is called it as the very much important regarding to the generation of the wind power. And also total wind power can be extracted in India, it is around 1.6 into 10 to the power of 7 megawatts. And where the wind can be expected, especially in the India, in order to harness through the help of windmills, that is called western Rajasthan, then coastal areas of Saurashtra and central part of the India. So from these places we can usually expect a lot of wind power. So next very important one, it is called what is the working of the windmill. That means what is the construction and working of the windmill. So the wind turbine, it is usually consists of hub with a specially designed blades. Okay, so wind turbine, it is usually consists of hub with a specially designed blades, and that is connected to the shaft. Next, the shaft is connected to electrical generator through this gearbox, and then this shaft, gearbox and the generator, it is completely enclosed in a housing, and that is called nacelle. Okay, then very important one, it is called, usually wind turbine consists of either 2 or 3 blades, and that are designed to extract the largest possible volume of air, and also these blades are mounted high above the ground level by means of the tower, mainly because of at the height increases, the kinetic energy of the wind is also increases. That's why the blades are kept high above the ground level by means of the tower. Then working is very simple. When kinetic energy of the wind is flows over the blades of the turbine, which converts kinetic energy into mechanical energy in the form of rotation of the shaft, and which in turn drives the electrical generator to produce the electricity. So this is regarding to the wind power. I repeat, here the wind turbine, it mainly consists of hub with a specially designed blades that are connected to the shaft. Then shaft is connected to the electrical generator through gearbox. Then gearbox and electrical generator is completely enclosed in the housing, that is called nacelle. And this wind turbine, it is usually consists of either 2 or 3 blades that are designed to extract the largest possible volume of air, and it is mounted high above the ground level by means of the tower. Then when wind flows over the blades of the turbine, which converts kinetic energy of the wind into mechanical energy in the form of rotation of the shaft, which in turn drives the electrical generator to produce the electricity. So this is regarding to the wind power. Thank you.